how important is for mathematicians and for people that are studying something related with math and sometimes something that is not related with math to understand graphs and to understand functions. So this is why in this video you're going to see one way to analyze trigonometric functions. You can see on my YouTube and in many videos other forms to analyze trigonometric functions, and this is just one of many proposals we have. So the idea is to analyze this function that you can see on the on your screen, and if you want to work a little bit with that before seeing this video, there's no problem. You can just pause the video and work by your own to see how to analyze the function. But this is the way I usually or this is the way I like to show how to analyze a function. The first part is to see what are the transformations applied to the main function or to the parent function. Okay, so what are the transformations? In this case, the parent function or the main function is sine of x. Okay, I think that this topic of transformations is very important to analyze functions because it helps you to take a parent function and sketch or have an idea of the function without doing the graph. And yes, I know that you can have many programs to do graphs, but analyze the function is like another skill that helps you to understand the function, not only see the function by the graph. And here is the transformations of the function. So I'm just going to pass very quickly by the transformations of the function. You can see another video in YouTube that explains transformations, but here I'm just going to do very quickly. Look at that. The first transformation that you can see is that this plus pi 6. That means that there's a shifted to the left pi 6 units. Okay, that's the first transformation. So when we shift it to the left, this sine function becomes sine of x plus pi 6. Now we can see this 1/3 that is just a stretch horizontally 3 units. Okay, so the parent function becomes x thirds or 1/3 of x plus pi 6. Then the next step is related with this negative sign, that is just a reflection about y-axis. Okay, so the parent function becomes minus x thirds plus pi 6. And now we're going to focus on this 5, that is an stretch vertically 5 units. So it becomes 5 sine of minus x thirds plus pi 6. And then we have here a negative sign, so it's a reflection about x-axis, so minus 5 sine of negative x thirds plus pi 6. And finally the last one is with this 2 that is just shifted up, shift up 2 units. Okay, so it will be minus 5 sine of negative 1/3 of x plus pi 6 plus 2. Okay, so we have noticed all the transformations. Now what I'm going to do is to apply the transformations to the original function sign, and then I can see the sketch of the graph. And this is the way that I propose for you to do the situation. As I'm telling you, it's not only one. You can have many ways to do it, but this is my proposal for you. My proposal for you is that remember the parent function sign. So okay, this is exactly the way I do it. I'm not gonna tell you that I do excellent lines or something like that. There is no such thing, because I'm sketching because I'm trying to apply the transformations to the parent function sign, so I'm not going to take care too much of this graph. I'm going to take care a lot of the final graph. So remember that we have pi halves, pi, 3 pi halves, and 2 pi, and the sine function is something like this. Okay, got it? And this is 1, this is 0, this is -1. Okay, as you can see, the sketch of this graph is not quite excellent, but let me correct it a little bit. In my board I do it better, but you know, I'm here in my bed doing this, so it's not going to be excellent, but this is the idea. Now what I'm going to do is to apply the transformations, and using the transformations to see the new scales or the new sketch of the graph. So look at that. The first transformation that I found was shifted left pi 6. Notice that these three transformations are related with the x coordinate, and these three are related with the y coordinate. And look at that, I use in the x coordinate, I prefer to start with the shifted left, and in the y coordinate I finish with the shifted up. Okay, it depends on the function, but this type of functions in which there are no parentheses inside the argument or parentheses outside, this is the best way to organize the transformations. First shifted left, and the last is shifted up. Okay, now what's gonna happen? I shifted left pi 6 units. So if I shifted to the left pi 6 units, means that this point was moved to the left pi 6 units. So it means that 0, the point here, now is not here on 0, but on negative pi 6. And what happened to these pi halves? So to these pi halves, I just shifted to the left, so pi halves minus pi 6. I can just multiply by 3 to have 3 pi 6, 2 pi 6. That is pi thirds. Okay, so this point now becomes pi thirds. And pi, what happened to pi? So I can do the same, pi minus pi 6, so 6, 6, 5 pi 6. So okay, 5 pi 6. What happened to 3 pi halves? So 3 pi halves minus pi 6, so multiply by 3, 9 pi 6, 8 pi 6, 4 and 3, 4 pi thirds, 4 pi thirds. And here in the other point is 2 pi minus pi sixth equals to so let's multiply by 6, 12 by 6, 11 pi 6. Okay, so this is the first part of 11 pi 6. Okay, notice that I shifted to the left, and I know the new scale. Now what is the next? The next part says stretch horizontally 3 units. So what means stretch horizontally 3 units? That these points are stretched according to the 0. The 0 here is like in this position. Now the 0 is like here, but it's going to be stretched by this position. What means is that I have to multiply these numbers by 3, because it's stretching 3 units. So let's use the blue to write the part of the stretching, it will be minus 3 pi 6. 3 pi 6 is minus pi halves. Multiplied by 3, so this becomes pi. This will becomes 5 pi halves, because I multiply by 3, just simplify. Here this becomes 4 pi, and this will become 11 pi halves. Okay, so this is what happened when I stretch horizontally 3 units. And the last is reflect about y-axis, and the reflection about y-axis is just a change that we made on the scale. So the positive of x becomes negative, so it means that this point will be pi halves, that will be negative pi, that will be negative 5 pi halves, that will be negative 4 pi, that will be negative 11 pi halves. Okay, so that's what happened with the transformations for x. Now transformations with y. What happened to the transformations with y? Transformations with y. So the first says stretch vertically 5 units. So if I stretch vertically the function 5 units, what's going to happen is that the 1 becomes a 5 because I multiply by 5. The 0 still 0, and if I stretch, the negative 1 becomes negative 5. Okay, that's the first part. And on the other hand, we're gonna have a reflection about x-axis. So what happens if I reflect about the x-axis? If I reflect about the x-axis, means that the positives becomes negatives and the negatives become positives. So it will be negative 5 here, 0 and 5. Okay, and finally shifted up 2 units. So if I shift it up negative 5 2 units, means that it becomes negative 3, this 0 becomes 2, and this 5 becomes 7. Okay, so notice that with this scale, with this new scale, I have many information of the function. A lot of information from the function. So for example, using this graph, I can know right now the domain. So as you could notice, the domain is not changing because I didn't do anything to have asymptotes for x. And what happened to the range? Look at that, the range of sign is given here, negative 1 and 1, but according to the transformations, the new range is here, negative 3 and 7. So I can know the range. The range is going to be negative 3 and 7. Okay? And notice that I can know the position of the maximum and the minimum points. Look at that, the minimum point is on negative 3, the maximum point is on 7, and I can know what is the x that gets you the minimum and the maximum. Look at that, the minimum is at pi, and the maximum is at 7. Okay, so minimum points, the first minimum point will be at x equals pi, and the maximum points are at negative 4 pi. Okay, negative pi and negative 4 pi. So negative pi, and the maximum point, that is 7, look at here, 7, the maximum point is with negative 4 pi. Okay, and as a periodic function, I just need to add the period. And how to determine the period? Remember that the period is completely related with the stretch or compress horizontally. So the period was 2 pi, but I stretched the function 3 units, so times 3, the period becomes 6 pi. Another way to find the period is just to subtract pi halves minus 11 pi halves, and you're gonna get 6 pi. So what I just have to do is to add n times the period, so 6n pi and 6n pi. Okay, and just by factoring pi, I just have 6n minus 1 pi for the minimum points, position for x, and 6n minus 4 pi, the position for y, for the maximum points of x. And this is what you can see here just by seeing the transformations and just by applying this analyzing of the function. Okay, I'm not going to overcharge this video with more information. I hope that you get that what we did was finding the transformations, and using the transformations we just rescale the sine function, and it's rescaling the same function we get information important as domain range, position of minimum points, and position of maximum points. In the next video about this part, we're going to see how to sketch the graph and how to find the intercepts of the graph. Okay, but that's going to be part of a next video, because this part, I prefer that you check this part and take your notes and do an analysis of that. Write on the comments if you have any question or some information about, and we can continue in the next video. So this is my greetings to all the people that are following me, especially for my students of 9th grade, that I hope that they watch this video. And have a nice day. Remember that you can follow me at any place. On my mark is UgoFim, and you can follow me on Instagram, Facebook, and anything using UgoFim. So see you in the next video, and I hope you have an excellent time. Goodbye.